Yeah. What is cost? What are the basic concepts of cost like marginal cost, incremental cost, sunk costs? Then we have also discussed about the um, basic concepts of cost we have discussed. Let us see how they appear if they put them on graph. Basic cost curves, let us understand. This I have drawn two curves here. The one curve is if the cost in short run, we have to discuss the cost curves according to the time. In short run, cost curves behave differently. In the long run, they behave differently. Then immediately you will ask me, what do you mean by short run? What do you mean by long run? See, if my input combinations, if I am able to change them, um, all inputs I can change them, then it is called long run. Let us say land, labor, capital, organization. These four inputs. If I can purchase new land, if I can purchase new building, a big furnace or a big machine, I have time to purchase that much and then produce the products. It's a long run. Whereas the machine is given, building is given, factory is given, only number of laborers I can change, or the capital I can change, only capital and labor only can I can change. We say it's a short run. Other costs we call them as fixed costs. The rent that I pay will be a fixed cost. Why should I say fixed cost? It is fixed. I entered into an agreement with the lease fellow that I will pay him rent monthly 1 lakh rupees for a coming period of 5 years. No problem. Then that 1 lakh rupees per month which I am paying is a fixed cost. So like that, whereas if I take the labor, if there is a production, I will engage more number of laborers. If there is no production, I will lay off them. I don't pay anything to them. So that is called direct cost, or it is also called variable cost. One which varies with the quantity of output is called variable cost. So if variable quantity of variable is increasing, cost also will increase. If quantity of output is reduced, cost also will reduce. You must have seen in the again during the lockdown period, many people have sent the people out. They have dismissed the jobs and they are now recruiting again. So that is called variable cost. Whereas they don't retrench the managing director who has to be paid salaries, who has to plan. So like that, you have a fixed cost, you have variable cost. How do fixed cost curve appear on a graph paper? I have taken a square ruled paper intentionally. You can assume each centimeter as each one square is 1 centimeter. So x-axis you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and again 10 here. So 10 centimeters this side, 10 centimeters that side. So quantity of output, let us say I will be taking what do you say, 1 here, 2 here. Yeah, let me take red color. 1 here, 2 here, 3 here, 4, 5, 6, 7, 8, 9, 10. Suppose there are 10 units of output, I am x-axis. And cost also, let us say it is $10, $20, $30, $40, $50, $60, $70, $80, $90, like that. At $50, if you take, we have incurred lease amounts, which amounts, let us say, $50. So $50 to produce 0 units also I have to pay $50. For 1 unit also I pay $50. 2 units also $50. 10 units also $50. Therefore, if I join these things, I get a straight horizontal curve which is called as total fixed cost curve, TFC, total fixed cost curve. Similarly, if I engage labor, I will not be engaging labor when my production does not start. So at zero level, my labor cost is zero. Please see, I have not started at zero. I have started here because this part is the total fixed cost curve, which I have shown you there, which I have to incur. So this fixed cost curve is total fixed cost curve. From here, if I increase 1 unit, I have out cost there. Variable cost is here, total variable cost, total variable cost, total variable cost, total variable, total variable. If I join all these points, I will get a curve, straight line, assuming that the constant ratio at which it grows. This is total variable cost. I hope I am clear. Now, having understood this, let us see what happens cost per unit. That means this $50 divided by 0 is 50, assuming 0 not to be infinite. Okay. Then second, if I produce 1 unit also, 50 divided by 1 is 50. 50 divided by 2 is like that, it comes down. 50 divided by 2 is 25. 50 divided by 3 is 16.33. Like that, the curve will be falling down. So you can see that the curve will be falling from here to here. The shape of the curve will be parabolic, and it is parabolic to the origin of 0. So from this 0, you can find that at parabolic, you have a parabolic curve. That means if I am producing only 1 unit, it will be here. For 1 unit, my cost is very high because entire $50 is here. If I produce 2 units, I am getting here. By 2 units, I will be getting half of that will come down. 50 divided by 2 is 25. And if I have 3 units, 50 divided by 3, it will be 16 units. Or here, it will be 16 units. Less than that. Okay, 16 units. If it is 4 units, it will be 12.5. Like that, it will come down. But it will never touch 0. Please remember, it will never touch the x-axis. But it will be parallel to it. So this is a parabolic curve which falls, moves parabolic to the 0, average fixed cost curve. So total fixed cost curve is horizontal and this is falling curve. Whereas average variable cost will not be falling curve but increasing curve. Initially, yes, if you are producing only 1 unit, definitely the cost will be high. But if you are producing 2 units, let us say, you don't have to engage one more laborer. If for 1 unit of labor, you are engaging 3 workers, 1 supervisor, 2 workers are there. They are producing only 1 unit. They themselves can produce 2 units. So you don't have to, spend money. The money will be same, but you can spread it. 2 units can be produced. And it will further fall down because per unit will come down. Because when you are producing 1 unit, 3 divided by 1 is 3. And here it is 2 you are producing, 3 by 2. 3 by 2 will be your cost, 1.5 each. If you are producing 3, 1 unit each. But after that, it will go up because one person cannot produce more than 3. So you need to recruit one more laborer. So laborer is increased, cost is increased. Labor is increased, cost increased. Labor is increased, cost increased. So as you go on increasing the number of units of labor, your quantity also goes up. So this is what we call it as increasing curve. This is average variable cost curve. So this curve goes up and this curve comes down. When you combine these two, you will get the total cost curve. And that total cost curve is the average fixed cost curve is contributing for the fall, and average variable cost curve is contributing for the higher. Together, total cost curve will have a U shape. It will have a U shape, and this is considered to be the minimum point at which you are having optimum production of goods. So this is called optimum production, and if you produce more than this, your cost will be, average total cost will be increasing. You have to remember this one as C1. So this is the basic concept of cost curves. So basic curves, once you understand them, now we can go for a what do you call? Suppose you have 4 plants and 4 plants at different sizes. Initially, you start with a small number of units and small firm and small machinery, etc. So you have a small average cost curve. So if you take average cost curve, this is called SAC, small short run average cost curve. It is called short run because we are taking a smaller period, shorter period, and first production. The first production, when you produce it, you will have a short run average cost curve which is U shape, and it will be minimum point is here. From there, if you declare a perpendicular, it will be Q1 here. However, if you purchase another plant over a shorter period of 6 months or one year, you can have another short run cost curve along with both machines together. You can have a SAC2, and this SAC2 will have a minimum cost curve separately. Similarly, you increase one more cost curve. That means one more plant you purchase and you expand. That will be SAC3. But when you go for SAC4, there is a danger that your minimum base point will be going up from the minimum point here. As in first SAC1 was having a minimum point here, it has come down to here, and it has again come down here, but here it has gone up. If you increase further, it will go further up also. It is because in a longer period, the product may become fatigue, machines may become fatigue, and you need to invest more, and that is more dangerous. So this is what we call it as short run cost curves also will have U shape only, but the minimum point gets raised after you reach the lowest point here. So if you draw an envelope curve to this is called long run cost curve or long run average cost curve, LAC. This is called envelope curve. It will be a tangent to the minimum points of all the curves, which we will see in our next figure. Let me show you the next figure, that also, and then I'll come to the theory part, explanation part as such. In fact, I'm already covering the theory point. The rate of output I have taken on the x-axis, and cost I have taken on the y-axis. You have a short-run average cost curve for the first plant, second plant, third plant, fourth plant, fifth plant, sixth plant, and seventh plant. Like that, I go on increasing different plants and then their cost curves. All those cost curves, envelope curve will be the long run average cost curve, which is in U shape. And the minimum point here, if you take into account, and that minimum point is the point at which, if you extend, this is a long run curve. Please remember, long run curve is envelope curve, superimposed curve, not a reality curve. Whereas these short run curves are the reality curves which can be scaled and measured as per the output. Therefore, you have, this is imaginary envelope curve. Don't take this curve as basis, but this is the minimum curve. Where is it intersecting with the SAC curve? It is interacting with SAC 4 here. It is interacting with the SAC 3 here. Two curves are there. So SAC 3 here or SAC 4 here, these two are considered to be the optimum output points. And like that, if you suppose at this point you are not producing, but you have increased your output. You have increased, let us say here. Then your cost curve SAC3 cost is here. It will not be optimum. And similarly, this side, if you take into account, it will extend to this. And if you extend here, here will be the output, it will be more. This is also more cost and this is also more cost, but this is the lowest cost. Hence, this is considered to be optimum point. So what we need to understand is SACs are real curves. And if you look to the marginal cost, which we have discussed, our additional cost for additional product, in a large marginal cost will be more sharper and it will intersect with the point here only. And that point is considered to be the optimum output. So this is about the short run cost curves. Same thing I have explained here, interpretation of long run cost curve. Only one point at a very small arc of each short run cost curve lie on the long run average cost function. Thus, long run average cost function can be shown as a smooth U-shaped curve, and then corresponding to the long run average cost function is a long run marginal cost curve, which we have shown. It intersects with the LAC at its minimum point, and which is also the minimum point of short run average cost curve of at least two SAC4 and SAC3 we have seen. And short run marginal cost curve corresponds with the short run average cost function of so and so, and all average short run average cost function, which is equal to SMC, that is short run marginal cost, which should be equal to long run average cost curve and long run marginal cost curve. This equation is very important, and you find long run cost curve serves the long run planning mechanism for the firm, and this we have already discussed this point. I think I'll stop here because special topics, if needed, we can learn. Thank you.